Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 9 in our incredible new tutorial series where you're knowing where you're going with your ultimate GPS tracker project. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee, poured over ice, no sugar, no sweeteners, none needed. And besides pouring your coffee, I am also going to need you to get out your GPS tracker project. I will show mine here. And this is where I am basically the homework solution to the assignment that I gave you in lesson number 8. So I must start by asking you, how many of you were successful? How many of you were able to get your GPS tracker working with an OLED connected to the circuit? If you were successful, leave a comment down below. I am legend. Double chest bump. And if you are not successful, leave a comment down below. I folded up like a cheap Walmart lawn chair. Now, if you didn't get it, never fear. In today's video, I'm going to show you my solution to that homework assignment, okay? And so we will get you caught up to where I am by the end of this lesson. But hopefully some of you guys were able to do it, because if you took my Raspberry Pi Pico W class, we did quite a bit of work with that OLED, so you should be pretty comfortable with it. Okay, now enough of this introductory banter. Let's go ahead over to our desktop view, and what I'm going to need you to do is call up your browser. I'm going to need you to call up your browser and go to the most excellent www.toptechboy.com. You're going to use this happy little search tool over here, and you're going to search on something like parsing GPS NMEA sentences with the Raspberry Pi Pico W, because we want to start this week where we left off last week, so we don't want to have to go in and generate all that code from scratch. So we're going to click on this to snag that code. We're going to come over here and we're going to paste that code, and now we're just going to see if we are able to copy and paste and see if this thing runs now. And so there is the junk we read and printed, and look at that, it is up and running. And look at that, we have 9 satellites. We're not moving 0.1 knots. Our heading doesn't mean anything because we're not moving. And then we have a nice clean lat lawn there. So everything seems to be working properly. If I do a Control-C, I terminate, I clean the UART, and I terminate the thread cleanly. So things are very good there. Now, the next thing I'm going to need you to do is, it would probably be a good idea if we are working on the same schematic. So I added my OLED over there, and you can find my schematic if you search on Raspberry Pi Pico GPS tracker with OLED display. You'll come here. Now, there is a couple of subtleties here I do need to point out. Let me see if I click on that, I can get it to come up bigger. Yeah, there, that looks good. I'll get a little smaller. So we've got the SSD1306 OLED here. Now, remember, I'd said that on my GPS, I kind of convinced myself I had trouble getting a fix if I powered the GPS with 3.3 volts on this 3.3 volt pin. And so I power my GPS with VN, and I power it with the 5 volts that comes from the most excellent pin number 40, which is just the V bus. It's basically the 5 volts that is coming in from the USB cable. That powers up this rail, and then that powers up the GPS. But we got to remember that fundamentally the Raspberry Pi Pico W is a 3.3 volt device, and therefore if we're going to be talking to something over I2C, we need to power it at 3.3 volts. And so while on our OLED the ground is connected to ground, the VN or VDD comes over, and it is connected to pin 36, which is the 3.3 volt out. So you can see we sort of had to cross over there. I don't think there's a convenient 3.3 volt rail up here, so we had to kind of go around the old horn to get that hooked up. Okay, so that has us hooked up, and hopefully now we are in the same location. This is my setup here. You can see by looking at the GPS, we already have a fix there because it's that very slow blink, and therefore we know we have a fix. Okay, so now how do we get started? Well, we need to come up to the top and we need to kind of set up that OLED. All right, so we import thread here. And then after importing thread, I'm going to say from SSD1306, I'm going to import SSD uppercase 1306 underscore I2C, like that. Okay. Now I'm going to go ahead and set up my I2C. So I'm going to call my I2C object I2C2, and that's going to be equal to I2C, okay? And I'm going to use bus 1, and then the SDA is going to be equal to pin 2, all right? And the SCL is going to be equal to pin 3. If you're doing things according to my schematic and according to the circuit here, that's what you would do. And then we use the standard frequency. FREQ is going to be equal to 400,000, like that. Okay. Now we're going to create our display object, and I'm going to put a blank line there, okay, and a blank line there. So I'm going to say our display object is going to be called DSP, and that's going to be equal to SSD 1306 underscore I2C, all uppercase. Be careful about that. This has 128 columns. It has 64 lines, and we are using I2C2, that object that we created. Why did I call it I2C2? Just because anything I2C, it might be like, in my mind, might be a reserved word, so I just want to put something there to make sure that I'm not somehow using some sort of reserved or special word. Okay. So that is all set up. Now, the next thing I want to do is I've got it set up. Now, before I forget it, I want to clean it up. Okay, I want to get it cleaned up. And so when we come all the way to the bottom of the program where we are cleaning things up, after this last time.sleep, I want to DSP. I want to fill the display with zeros, and then I want to DSP.show. There's probably other ways to do this, but I just want to make sure I blink the screen when I exit the program. Otherwise, I'll run the program again and I'll look down and say, oh, it's working, but it's just that remnant image from the last time that I ran the program, if that makes sense. Okay, now we're going to come up here, and before, what were we doing in our main loop? Well, we were going out and we were getting the dictionary that was created by that other core, the other thread that is constantly updating the dictionary, and it is updating NMEA NMEA data. Okay, well, what I do is I lock NMEA data. I make my own copy of NMEA data, and then I unlock, because I don't want to be monkeying around with the dictionary when that other core is having to stay ahead of the data coming into the buffer on the UART. I don't want to mess with it. I want to get in, get my copy, and get out. Okay, so now what will I be working with? I will be working with this one, which is my local copy. Now, I'm not changing it or anything. I'm just getting data out of it and doing useful things. Okay. Now, what I want to call is parse GPS, which takes that NMEA main, which is one big, huge data structure, and it breaks it up, and it breaks those NMEA sentences up into the things that we care about, like latitude, longitude, speed, direction, number of satellites, things like that. Okay, now here what I'm doing is I am printing. And so if I don't have a fix, I say waiting for fix. If I do have a fix, I print out my useful data. Well, what else do I want to do now? In today's lesson, what I want to do is I want to display that also on the OLED. So I call that function. Guess what? That function isn't there, so we need to go up and we need to define that function. And so what I'm going to do here after that thread, right, or this is after the GPS parse, right, this is the parse GPS. After that function, what I'm going to do is define display OLED like that, okay? And now the first thing that I always want to do is DSP, that's my OLED, and I want to fill it with 0, so I'm going to blank it out. And now if GPS data, okay, of the index fix, if that is equal false, then what do I want to do? I want to DSP.text, and I want to say waiting for a fix. Okay, like that. And then I'm going to put that at, this is going to be column 0, and this is going to be row 0. Okay, column row. I guess the easier way to do it is X and Y. So X is 0 and Y is 0. All right. And now what is the other case? Well, if GPS data of fix equal true, that means we do have a fix. Now this is where the action happens. This is where the action happens. I want to come in now and I want to put the useful information on the screen. And so the first thing I'll do is dsp.text, and then what I will say is this is the ultimate, I think I'll use all caps on this, ultimate GPS space, and then I'll close that quote, and I want to put that at I want to put that at a y value. I want to put that at an x value of 0 and a y value of 0. Okay, so it's going to be up in the corner. It's going to start in the corner at 0, 0. All right. Now what I want to do is I want to dsp.text. And then what do I want to do? My first useful information is going to be the latitude, lat. With these little displays, you got to use a lot of abbreviations to get stuff to fix. So I've got lat, and then I want to concatenate that with the string value of GPS data. And what is the data that I want? I want lat DD for lat decimal degrees. Okay, and now we are going to close that, and then where do I want that? I want that at 0 and then 16. So that would be a y value of 16 down, which should sort of be like the next line. Okay, and it looks like I didn't close something there. What did I not close? The string value of GPS data. Like that, got to close that string. I am going to now come down here. There's a lot of other things that we're going to want to print, right? But I'm going to go ahead and just do a dsp.show so I don't forget. And now I'm going to run this thing just to see if the OLED does anything. I like to take the small victories where I can. So let's run this thing. And what you can see is it's got the junk and it doesn't like line 91. What is that nonsense? Display OLED doesn't like DAT-DD. How about we do lat decimal degrees? Okay, lat decimal degrees. That one scared me a little bit. Okay, we are, and you know what? We didn't do a clean exit. So we did not exit that thing cleanly, even though we put that excellent shutdown, and this thing is locked up hard. So I'm going to have to unplug it, and then I'm going to plug it back in. And now I am going to connect to it. You see, I put that Control-C thing in there too, just for such an occasion, so we don't have that problem. But the Control-C shutdown only does you good if you hit Control-C. And I use the stop button. Okay, so now let's run it again. And then there, thread running, we've got our junk, and then boom, look at that. Ultimate GPS, let me come over here. Ultimate GPS, and I've got a lat value, and it only updates every 10 seconds, but yeah, it did update there. Okay, so what is the good news is? The good news is that we are really on a good track. Now, I kind of wonder, I'm going to do a Control-C. I'm wondering if I can reduce that gap any, like what if we said 14, because it was a pretty big space, and given that this is a small screen, we don't want to waste anything at all. So now I'm running it again. No, you see, I can't change that because I go up into the yellow. And so I'll Control-C. I realize that you didn't see what I just did, but it's okay because I'm going to undo it, and I'm going to put this back at 16. I'm going to put this back at 16. Okay, so now I think I'm going to take this because most of the next lines are going to be very similar to this. And so now instead of lat, what am I going to want? I am going to want lon. Okay, and then here the GPS data is not going to be lat, it's going to be what? The lon DD for digital degrees. And here I'm going to drop down another 10 pixels, and so this will be 26. All right, and now we will paste again, and I've got lat, I've got lon. Now I want speed. Okay, and that is speed is going to be GPS data, and it's going to be knots, like that. And then I'm going to go ahead and concatenate that with the label KNTS, and then I'm going to close that. All right, I hope that works. I'm going to run that one, okay? And then we're looking down here, and boom, I've got a mistake. What did I do? What did I do? Let me come over here. What did I do? I go 16, 26, and this should have been what? 36. So I'm going to do my cool. I'll let you see what's going on again. I'm going to do my cool Control-C, Control-C, and it is terminating, and boom, did you see the display went off? So that's very good. Now I've got the 36 in, and let's see what happens here. And we are waiting for a fix. How did I lose a fix? It'll find it. Okay, do you see though? It's good though because it's saying waiting for a fix, and boom, now it's got the fix. It says lat and lon, and then I've got my speed, and my speed is like 0.4 knots, which makes perfectly good sense. Okay, so we are moving right along here. Now I'm going to come over, and I'm going to Control V. I don't know what happened to my Control-C, so I'll Control-C again, and now I'll Control V. And so we have done speed. Now we need the heading, so I'll say head, and then for that, what we want is we are going to want the index or the key of heading, and then there the label is going to be degrees, like that. Okay, and up here on nuts, I'm going to put a space there so that, you know, it has a little bit of a space. Okay, so that's good. And so now I have heading, and now I'm going to paste. Man, I'm having trouble pasting today. Okay, so now what is the last thing that I want? I want the number of sats, and so that would be GPS data of sats, and then that is, I did 036, that should be 046, and now this should be 056. And were you seeing all that? Okay, so it's 0, 16, 26, 36, 46, and 56, like that. Okay, so we'll come back to this view. And then we have all of that set up. And so now let's run this thing. Okay, ooh, what is it not like in, what did I do wrong? 104 and then line 65. Well, what's line 104? Parse GPS, and then line 65. Okay, that's interesting. That is like, if I look at this GPT-VTG, that looks like a good sentence. That all looks good. Let's make sure that I am, you know, sometimes if you don't do, okay, yeah, you see I don't think that was a program error. I think that was the other core was still running the program. So let's do a hard reset. And guys, I really believe that if we would do Control-C, we wouldn't have that problem. So now we are going to come over here. We are going to connect. And now let's try running it. Okay. And there's our junk. And it already has a fix. And then look at that. I have the lat, the lon, the speed, the head, and the sats. I have 5 sats. But what do I see? I left the label on there. I left the, you probably can't see it as well as I can. I wonder if I can zoom in a little more. Do you think we can get that close? Maybe that's a little too close. And have it still focused. I'll have this working better next week for you, okay? It's about, you see I have on sats, I have 7 and then I left the degrees. Okay, so that wasn't good. So here, I just want the number of sats. I don't want to concatenate that with anything. So we'll take that off like that. This time we will Control-C, and I'm going to predict that this thing runs like a champ this time. This thing is going to run like a champ because I Control-C'd out of it. And we are going to start it, and boom, I have 8 satellites. And then we look over here and we can see the lat, we can see the lon, we can see our speed, we can see our heading, and we can see our number of satellites. Okay, and as I look at it, I have completely filled up the screen, so there's nothing else that we could put on there. So it's like you can pick like the 1, 2, 3, 4, 5 things that are most important for you and put those on there, the 5 things that are the most important for you, and put that on there. But then also, if you were really in a bind, you could not put the title, and you could put some useful data there as well. Okay, guys, I think we made some excellent progress here today. And so what your homework assignment is going to be is just kind of get caught up with where I am and play around and make sure that your GPS, you can run it, and the thing doesn't crash. Because as we're sitting and doing the development, it seems like it's working, and then there's that case that we haven't really been paying attention to. So it might even be good to kind of like let this thing run overnight and make sure that it can begin to run longer term without getting without the thing crashing. Okay, so I think that was pretty cool. What am I going to do next week? Okay, what am I going to do next week? I think the one other thing that might be useful for us to do, and I think I'll try to do this for next week, and in fact, this might be a homework assignment for you as well, that let me Control-C out of this. Do you see how I just make up homework on the fly? Okay, so I am going to come back over here, and I have Control-C, and I'm going to run this, and then as soon as I get that junk sentence, I'm going to kill it. And so this is our GPGGA, okay? And that has this 11/28/10/000, and that is like from an atomic clock. That is like the most accurate time that you could ever imagine. Now, there's a few milliseconds it takes for that signal to get from the satellite with the atomic clock down to you. But let me tell you, this is about as accurate as a time that you can get. And so what I want you to do is to take this and to parse it, and then to display on the OLED, besides the other information, I want you to display the time. Okay, I want you to display the time, if that makes sense. Now, I told you this is coordinated universal time, so you're going to have to convert universal time to your local clock time, and you're probably going to have to think about that a little bit in order to do that conversion. But that's going to be your homework assignment for next week. You'll get that up on the screen, and then what you do is we're kind of moving. You can imagine that what we're moving towards is a portable device. But let's get a little bit more working on the display before we officially go mobile. Okay, so we're going to do a little bit more with those NMEA sentences, and then we will be going mobile here very, very quickly. Okay, guys, I hope you're having as much fun taking this class as I am making it. It's at this point that I always give a great big shout out and a great big thank you to you guys who are standing with me on Patreon. Right now, it is the Patreon support that keeps me in the game and enables me to continue to produce quality, fresh content every single week. So big thank you to you guys. You can also help this video by giving it a thumbs up and leaving a comment down below. That helps with the old YouTube juice. If you haven't already, make sure you subscribe to the channel, and when you do, ring that bell so you'll get notification when future lessons drop. And as always, most importantly, share the video with other people, because the world needs more people knowing where they're going, and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.